Hi there, guys. Well, welcome back. We're about to start Unit 5. Unit 5 is Analyzing Data and Quantifying Randomness. So this is statistics and probability, although in fact, it's mostly statistics. There's not a lot of probability in this unit. So there's a lot of stuff in here if you look at the micro concepts, which we have done before, which you will have done before. We've got things like sampling, lots of definitions of samples and types of data. Then we're talking about presenting data, so histograms, frequency distributions, coming up with tables, group data there. And we've got some statistical measures as well. So mean, median, mode, quartiles, percentiles, standard deviation, variance, skew, box and whisker diagrams, outliers, all these sorts of things. And then also at the end of the chapter, we've also got correlation and regression lines as well. So there's things which you probably haven't seen there already. Now, even if you feel like a lot of this is pretty obvious, it's quite important to go carefully through each of the exercises and make sure that you have understood each of the definitions, because there will be definitions given for each of these concepts which you might not have considered before. Okay, what I wanted to say as well, just briefly, let's get rid of me. Okay, so briefly as well, that there is a little bit here on paper 3. So paper 3 is new to your HL course. In the previous HL course, there would have been an extra book, essentially, which would have been an option book, and you would have got a choice. And in fact, statistics would have been one of those choices and would have extended quite a bit further. But now you don't have that choice, and you just have the structure of your exams is slightly different, and you have a paper 3 exam. And so you have an hour to do 2 extended questions. And there's a little discussion about this one here as well. And I'll leave that for you to have a read through. And there's a little investigation here as well. They're trying to give you a sense as to kind of skills that are required for a paper 3 paper. Okay, well, I'll leave that there, and then let's go into these definitions. There's a little bit before you start, the things that you should know, for example, means and frequency tables. I'm not going to do them because after all, you should know them. And then it starts off by talking about sampling. So what I'm going to do here is just go through some of these definitions. And I'm pretty much going to read through them, but I'll try and bring them to life a little bit and come up with the particular examples when I can think of them. They talk about the Kinsey reports here. So there's a lot of kind of interesting little boxes they come up with here. So famous sampling issues. The Kinsey reports were translated into 13 languages, sold over 750,000 copies. They've been called some of the most influential scientific books of the 20th century. Interesting. Okay, actually, I don't know much about them. You can certainly research those. And I think there is an opportunity to research quite a bit here and to read further than just what's in this chapter. So, for example, they talk about Ronald Fisher here, and they say, you know, he lived between 1890 and 1962, lived in the UK and Australia, and described as a genius who almost single-handedly created the foundations for modern statistical science. So, although the term statistics has been around for hundreds of years, and obviously nation states, for example, have had to consider certain statistical problems for hundreds, if not thousands of years, a lot of the development of statistics actually happened in the 20th century. So it's quite a modern field in terms of mathematics. Now, it's kind of interesting if you read up on these characters, like Ronald Fisher, for example, who they're talking about, and also Carl Pearson. So Carl Pearson was an English mathematician and biostatistician. He's been credited with establishing the discipline of mathematical statistics. Right, okay, so that's Pearson. Whereas Ronald Fisher was credited as described as a genius almost single-handedly created the foundation for modern statistical science. So he's into statistical science. Carl Pearson is more into mathematical statistics, right? And you might be interested in reading about these guys. And some of these guys have given their names to things. For example, you'll find out about the correlation coefficient later on, which is often called the product moment correlation coefficient. Sometimes it's called Pearson's correlation coefficient. Now, you should know about this, that apart from these guys being super smart scientists and mathematicians, history is complicated because these guys also believed in, they also had things to do with natural selection. This guy is a great successor to Darwin. But then you can see, what does it say? There we go. He's a statistician, geneticist, and eugenicist. Now, likewise, when you see Carl Pearson, you'll also see Pearson was a proponent of social Darwinism and eugenics. Okay, well, if you don't know what eugenics is a set of beliefs and practices that aim to improve the genetic quality of a human population. And this is a topic now where we're talking about augmenting our abilities with technology, or selecting the right genes to sort of breed out diseases or illnesses, I suppose. Okay. But obviously this was also promoted by the Nazis. So it's a really complicated history here. And I'm not going to go too much into that, but I just wanted you to be aware that there's some really interesting reading here, which would, supplement your mathematics. And, IB is all about that. This sort of interest in one subject leads to an interest in another subject as well. But okay, so I'll leave that where it is, but just, bear in mind that these guys have sometimes been erased from history a little bit as well, because, for example, although we can't get rid of the statistics that's been created, we do now generally call this Pearson's product moment correlation coefficient the PPMCC. We often just drop the Pearson's now. We talk about the correlation coefficient, or R squared, or PMCC. We just sort of drop the Pearson's. Okay, well, actually, this is just interesting here. This is going to turn up later. It's talking about a way of, it's a statistic which measures linear correlation between two variables x and y. Now, again, often these things which are created, these statistics, don't give you a single way of doing things as well. Sometimes there could be an alternative version, but this one, for example, might be the best way of doing it, and generally the agreed upon way of doing it. And often they are backed by mathematical thinking and mathematical logic, but sometimes there are more than one way of doing things. So, for example, as a measure of central tendency, we've got our mean, median, and mode, which you should be aware of already. And they all have their benefits, but and they all have their reasons. But you can often, if you're trying to justify a case, you can use any one of the three. Sometimes. Okay, let's move on. So we're looking at some definitions here, that we're talking about a population and a sample. So population consists of every member in the group that you want to find out about. So if you were interested in interested in the school population, for example, if you were interested in finding out something about the students, something about the students within the school, then the population would be all of the students in the school. But a sample is a subset of that population, that will give you information about the population as a whole. Okay, and for 5B, they actually talk about sampling techniques too. So choosing a sample which gives a good representation of the population. Well, again, that turns up in 5B, but for 5A, they just talk a little bit about some of the some more terminology here. Now, a lot of this terminology you might want to use for an IA, but you're unlikely to be tested on this stuff here. So this is the target population is the population from which you want to take a sample. That's kind of similar to the population, isn't it? But maybe a population is also a subset of a target population rather is a subset of the whole population. We might be saying, well, we're only going to take our sample from this group because this is the group which we have access to. So it's slightly different, I think. And a sampling frame is simply a list of the items or people within the target population. So, for example, if you said, well, I've got access to people in my year group, and I want to find out something about the students in the school as a whole, but I'm just going to use my year group as the target population, then a sample frame for that would be a list of all of the students in your year group. Now, a sampling unit is a single member from the sampling frame chosen that's going to be sampled. In other words, one member of your sample, okay, this little group that you're choosing from the population. Okay, and a sampling variable is a variable under investigation. So, for example, if you're interested in shoe size, then although you might be looking to ask people in your year group, for example, that the shoe size is the sampling variable. That's the thing which we're interested in. That's the outcome, if you like. Okay, but the input are your sample units. Okay, and then it says the sampling values are the possible values which the sampling variable can take. So that would be, for example, if you're interested in shoe size, then we're talking about, well, what possible shoe sizes are there? Okay, so just some easy definitions there, really. Just checking through. I wonder if I just missed anything above. Yes, I did. Okay, I missed some stuff. Okay, well, there's a little investigation here as well. And there was also a little bit about qualitative and quantitative data, which is kind of hard to say, qualitative and quantitative data. Okay, and both ending in this tative. Okay, so qualitative data, or sometimes called categorical data, is described in words. So, it might be what's the color of your jumper? It might be how are you feeling today? That's what it's saying there. Happy, sad, And then it's and that's different to quantitative data, which is essentially numbers. And of course, it's the numbers, it's the quantitative data which we care about most in statistics. We're interested in how we can analyze data, the numerical data, that is. Okay, so they're coming up with some questions there which lead to numerical answers. Now, quantitative data can be put into two different categories. We can either say it's discrete or continuous. Now, continuous is the easier thing to describe here. Continuous is something like it's something that can be measured to ever greater accuracy. So, for example, if you were going to measure somebody's height, you could keep zooming in and zooming in and zooming in, and you could get that to more and more accuracy. So, maybe it's 1 meter 70, but in fact, you zoom in again, it's actually 1 meter 70, 0.1 centimeters. So, 170.1, and then you zoom in again, and in fact, it's 170.10. And then maybe it's 170.10000, and there's 100 zeros, but you can zoom in again, and at some point, you're going to get another digit, which could be a zero as well. But you can keep zooming in. So it says here, continuous data describes quantities that are measured, such as height, weight, or age. And the way I describe it is to say, these are measures which you can keep zooming in and measure ever more accurately. And discrete data describes quantities that are counted. Now, true, but shoe size would be discrete as well. Even if you have an 8.5 measurement, that's still discrete because you can't keep zooming into that. It's a category that exists, and it finishes. Right? It's not rounded off in any way. So you can have halves, you can have 0.1 if you like, you can have hundredths, but it stops at some point. Okay. Right. So it says Prices are usually thought of as continuous, even though in reality most currencies are not subdivided below units of 0.01 units, like cents or um, you know pence, for example. Okay, but in fact, yeah, that's true. Prices are usually thought of as continuous because when you're doing calculations, for example, when you're finding compound interest, you'll soon realize that you end up getting long strings of decimal answers. And we only just round off to the lowest currency unit because that's practical to do. But in fact, prices are generally treated as continuous when we're using them in financial situations. Okay, well, there you go. That's 5A. And I'm not going to go beyond that. That's just a little introduction. They actually give you a question here. I suppose we should look at the question. And then I'll do 5B separately, which is going to be a bit more discussion, in fact. So example 1 here says you must carry out a survey to estimate the number of children in the families that live in an apartment block. Given this context, define the target population. So the target population in this case is all of the apartments in the block. So let's just read the thing again. It says you must carry out a survey to estimate the number of children in the families that live in an apartment block. Okay, well, although the target population can be a subset of the entire population, actually here the entire population can be treated as the target population as well. So it's not too difficult to just say, well, here we go. Let's look at this entire apartment block and let's take a sample from this. That's the only thing we're interested in fact. That's the total population as well. So then it says the sampling unit. So the unit is, yeah, that's interesting. It says each apartment. That's interesting because I thought the sampling unit was defined. See what it says. Sampling unit is a single member from the sampling frame that is chosen to be sampled. Oh, well, in the definition there, it says it has been chosen to be sampled. But I think it should say that can be chosen to be sampled. That we can choose to be sampled. Okay, so it's not necessarily been picked. Okay, so there we go. It's saying the sampling unit here is each apartment, so they've not necessarily been picked. Then part C says the sampling frame is an itemized list of individual apartments. Okay, so just listing apartments 1 to 200 or whatever we've got. Part D, it says sampling variable. So the variable is the thing we're interested in, which is the number of children in the apartment. And part E says the sampling values is obviously what the values that we can get out from the variable. So what are the ages of these children? And we need to define child. I guess that goes up to 17 years old in most jurisdictions. Okay, so there we go. That's done. And there's some example questions here on 5A. And next time around, we'll talk about sampling techniques. Okay, well, thanks for listening, and good luck with the exercise, and hope to see you back next time.